Very good morning, kids. Welcome to St.Georgia Girls School, Hajipur. A big hi and welcome back, all my lovely kids. Class ninth. Again today we'll be winding up the chapter Is Matter Around Us Pure. We'll be covering the rest and the remaining separation techniques. Chromatography is one of the most recent and advanced techniques used for separation of individual components from the mixture based on the differences in their solubility with respect to the solvent. In paper chromatography, the specific compounds of the mixture get separated, and that separation is based on the differences of that compound to get soluble in the solvent or water. The component which is more soluble in water, it will rise up faster and higher in the stationary phase or the chromatography paper. Thus, the component that rises high in the chromatography paper can be separated easily from the rest of components. You can see in the diagram, it is used to separate the specific pigments of chlorophyll as well as proteins and amino acids. You can see when you put any specific mixture at the origin point, the component A is less soluble in the stationary phase, that is in the chromatography paper. Thus, you can see component A remains down, whereas component B is more soluble. So, it moves or rises up. You can see in the next diagram, each and every component of the chlorophyll is visible very clearly. The component which lies towards downwards is the one that is not more soluble. That means it is very less soluble with respect to the solvent. The component which has risen very fast, such as keratin or phyophytin, these components are more soluble with respect to solvent and thus have risen high on the stationary phase or the chromatography paper. Distillation is a method to separate components of a mixture based on the differences in their boiling points. The mixture has miscible liquids present in them. For example, when you want to separate ethanol or acetone from water, you heat the mixture. The ethanol starts evaporating and the vapors are obtained. These vapors are cooled down in the condenser and the pure ethanol is obtained in the receiving flask. Similarly, in fractional distillation, it is again used to separate components of the liquid which are miscible and they differ in their boiling points, but bare minimum is 5 degrees Celsius. When you want to separate gases from the air, this method is used. Or, for example, you can see in the diagram, the components of crude oil are separated based on the fractional distillation technique. That means the heat is applied to the crude oil. The vapors are formed of individual components of the mixture at specific boiling point which the component possesses, and the pure component is collected in the receiving flask. The crystallization method of purification is used when the impurity present in the mixture is more soluble in water than the substance to be purified. So in this scenarios, when the saturated solution of the mixture is cooled down, the pure crystals of the substance that needs to be separated are obtained, leaving out the impurities in the dissolved state itself. For example, it is CuSO4. As you can see, CuSO4 crystals are obtained from the mixture that contains impurities as well. It is also used in pharma industry. This method is used to separate either impurity or purity from the mixture if they possess some magnetic property, whether the impure part of the mixture or pure part. If they possess magnetic property, they get attracted to the magnet and thus get separated from the mixture. It is used to separate iron fillings from waste. Project work for you. You'll make a dummy model for separation of petroleum components. That means fractional distillation ka dummy model. In the second case, you can prepare a chart paper to explain your friends regarding the chromatography technique. You can mail me